we're going to start off by doing this train time. So the train time is the recommended application to do. The harder one, much harder one, is the multiplayer rock, paper, scissors with persistence. So let's work the train time one first. So we have this current train schedule. It says train name, destination, frequency, next arrival, and minutes away. Now, just as we looked at before with the other example that we had in class, we only need to put certain things inside of the database. So one of the things is the train name, the other one is the destination, and the frequency. From there, we can then calculate next arrival and minutes away. So I'm going to show you guys how to do this next arrival and minutes away. But from there, I want you guys to be able to just use your own knowledge to be able to figure out how to do these parts, because we did go over a very similar example in class of how to add these different things. So if I put train name and I put Crazy Arse Train, destination Jamaica, because all trains go to Jamaica for some reason, and the first train time is going to be 12:07, and military time. So if this was 1 o'clock, it would be, or repeat that. If it was 1:07, that's what it would be. Let's just put 1:07. Frequency is going to be in minutes, so let's just put every 15 minutes the train comes. And we have an alert. It says train successfully added, and you can see this Crazy Arse Train, destination is Jamaica, frequency is 15 minutes, and you can see the next arrival at 12:22, minutes away 14. So let's take a look at how to implement this in a much easier way. So, or in a much more structured format. So first off, let's take a look at the mathematics, because we already covered how to do some of the programming for this earlier, I think on Wednesday. So assume the following situation. So the first train of the day is at 3 o'clock a.m. Assume the train comes every 3 minutes. And assume the current time is 3:16. What time would the next train be? So using your brain first, we can then calculate, okay, well first let me give you guys a pause to try and calculate this. Alright, and hopefully you guys paused it. So if the train comes every 3 minutes and it starts off at 3, that means you have 3:03, 3:06, 3:09, 3:12, 3:15, and then 3:15 is before 3:16. So what we can do is then say, oh, okay, well if the next one is then 3:18, then we just do, okay, so we have 2 minutes left from 3:16, so that's 2 minutes away. Pretty simple calculations, right? Just basic arithmetic. The second test is going to be, first train of the day is 3 a.m. Assume train comes every 7 minutes. Assume the current time is 3:16. So very similar, except the interval is changed to 7 minutes. So now we say 3 o'clock, then 3:07, 3:14, and next one after that is 3:21. So then we have 3:16, but our previous interval was 3:14. So between 3:14 and 3:21, we have is 3:16. So you just subtract 7 minus 2, and you get 5 minutes away. So hopefully it's starting to make a little bit of sense. Now let's do it programmatically. So, oh, sorry. Even before we do it programmatically, we can do it mathematically. So for test case 1, we take 16, which is the number of minutes past 0, and we are taking that as being the current time, and then we have the first train time as being at 0. So we didn't have to calculate 3 because the number of hours were already calculated for us. So it's just 16 minus 0 is 16 minutes from the current time, or sorry, from the first time. So then what we do is we take the modulus of 3, because this is the interval. So you say 6 modulus 3, and this will give us the remainder. So what happens is we just take that interval and we subtract the remainder from it, and you get 2 minutes away. Now you simply add that 2 minutes away to the time that we had at the current time, and you get the next train schedule. Now it's going to be a little bit difficult to really gather your head around the first time, so I want you to really take a look at this and take a look at this and then see where they correlate. essentially this 16 is coming from here, this 0 is coming from here, then 16 again is coming from here, this 3 is coming from this, from this interval, and then this 1 is this remainder that we're getting from this modulus operator. Now, when you want to calculate like how many minutes left, then you can say, okay, well, we have this 3 minus 1 left, and that's how many minutes away it is, right? And then to calculate that in terms of, the actual time, we can just add that to this 16. So 2 plus 16 would be 318. And the same case goes with test case 2. So if we have 16 and we have 0, and that gives us 16 minutes. So we're 16 minutes in the current time from our initial time when the train first started. So we can see how many times this interval is run and how many minutes remain using this modulus. So if you do 16 modulus 7, then you say, okay, our remainder is 2, because 7 times 2 is 14, and the remainder is 2. So we have 2 modulus as the remainder. Subtract that from 7, which is the interval, and you get 5 minutes away. Now, to get exactly what time the next train is going to come, we just do 16 plus 5, which is going to be at 3:21. All right, so now let's do that programmatically. So we have t frequency, which is the time frequency, every how many times in terms of minutes the train runs. So either t frequency is train frequency or time frequency. I'm not really sure. It's probably train frequency. Is 3 minutes. The first time we're just going to say is, okay, 3:30 a.m. is the first time this runs, right? And what they've done over here is they said they pushed back 1 year to make sure that the first train time comes before the current time. We don't want this to happen before our current time, because that wouldn't make any sense. You don't want the train to run backwards in time, unless you're in Back to the Future, which would be kind of cool. Smoothie. All right, so let's use our moment.js file again to do some conversions. So we have our first time converted. We just take our first time, which is going to be at 0330, and format it into hour, minute, and then use this subtract method on moment.js to then set it back 1 year. So whatever the time is going to be, it's in datetime format now, and it's set back by 1 year. And this is all in moment.js. It takes care of this for you. So that's the syntax in order to do that. Next, we console log that out to make sure we're getting the right data. So let me just refresh this page and go to console, and we get this crazy first time converted object, which is going to have, this is what we're looking for, Wednesday, August 12th, 2015, 0330 GMT. So this is 1 year from the current time. So this is working just as it should. It gives us back this weird object with a whole bunch of different properties and values, but essentially it has the information that we want. So moment, again, we set it to today, an hour, in minutes at 3:30 a.m. And then we just subtracted 1 from that. So today is August 12th, and we're setting the time to be 3:30 a.m. GMT. Notice that this is in PST. Even though I'm in PST, it doesn't recognize my timestamp. And so 2016 is 2015 because we did that subtract over here. Now we console log that out, so we see this weird little object. Don't worry about that for now. What we're going to do is we're going to go to the next step. So this is going to be the same thing as we did mathematically, except now we're doing it programmatically. So now we have our current time. Current time is just the moment with empty parentheses. So we just want to save this to a variable so that it makes more sense. So what we can do is say current time is concatenated with this current time, and then format that to hour, minute. Now I could have just left it like this and taken all of this out, and it would have done the same thing. But we wanted to be more explicit and be able to save the current time into a variable so we can use later. And it looks nicer too, just to have this current time to see instead of just saying moment, and some people might not know what that means. But when you have moment without any arguments being passed in, that just means it's the current time. All right, and then again, formatting it to hour, minute, minute. So if I did that, hit refresh, it's 12:17. If you can see over here, it's 12:17, so that's correct. Now we have this variable diff time, so this is the difference in time. So if we take moment, this is again our current time, and say the diff using moment.js, that gives us the difference between our current time, and then this gives us the difference between that and whatever time we want from there. So we have our first time converted, which was here. So what's the amount of time that's passed between 3:30 a.m. and my current time? So remember, this is 3:30 a.m. 1 year from today. So this is 527,567. So that is in minutes. Okay. Yeah, so it looks like it converted to minutes. If I put it in hour, month to month, it should make it look, no, that doesn't do it. Okay. Let's just leave it at minutes. Oh, I'd have to use dot format. Well, it's fine. Let's just leave it in minutes. I think we needed to use the amount of minutes anyway because we use minutes over here. So we're just leaving it at minutes. So this is the amount of minutes between right now and 1 year ago at 3:30 a.m. Now you can say, okay, so what's the time apart? So again, this is going back to how we did something over here. So if we have the t remainder, that's a variable, and we just take this difference in time in minutes, right? So just like we did here, the total amount of minutes, and the t frequency, which is, sorry, so this is the difference in time, not this. So this is the difference in time that we did, right? So we did this subtraction, and now we have this difference in time over here, and now we're doing this modulus operator. Same thing over here, we're taking this t frequency. So over here is 3. We're going to use this 3, and we're just going to do, the difference in time modulus the t frequency and see what our remainder is. And that remainder is going to be stored in here. So to log that, we can see that over here, and we have 1. So very small number, right? There's not that much of a difference. So the minute until train, so minutes until train arrives, is t minutes till train, which is a variable that we created. And again, that's just this one. Or the total is this one, which is equal to this. And this t frequency is going to be this over here. So ours is 3. So we have it from here, 3. Minus t remainder, which we got as 1, remember over here. So 3 minus 1, according to the math that I last remember, is 2. So minutes till train is 2. Finally, we have our next train, which is a variable. Our next train is set to moment.add. So we, again, are doing the same thing with this calculation. So take the minutes away and add it to our existing time. So we do our current time, and we just add minutes till train, which we have over here. And we put that in minutes, and we can just put that in arrival time, and we have 12:21. And that's it. If you guys don't have this file, please let me know. If you guys have any questions, let me know as well. But this should be somewhat straightforward. It's a little complicated, but this should really help you out with completing the homework. along with the other one that I posted. The other one that I posted is only for the persistence video, is mostly about the second homework. This one is just about the easier homework. All right, take care, guys.